Hello everyone, hope you are doing good and welcome back to my channel. Today we are at day 3 of the January daily Leetcode challenge. On day 1 and day 2 we had some good questions, but they were not very hard. They were on the easier side. And let's see what we have for today. It's question 2125, number of laser beams in a bank. So let us see what are the inputs given. So you can see that we are given a bank array, and each element in this array is actually a binary string. We can call it as a binary string because it has only zeros and ones present, and ultimately we have to return integer as the output. Okay, believe me, this question is simple, but if you go through this you will feel like there is something very difficult thing given. But don't worry, once you will go through the theoretical description also, but after that we will see this picture, this picture, and we'll try to understand what is happening. Believe me, it's very very simple. So let me go through it. So anti-theft security devices are activated inside a bank. So obviously we are talking of banks, so we are also talking about this security and anti-theft and all those things, right? You are given a zero index binary string array called bank, representing the floor plan of a bank, okay, which is a m into n 2D matrix. Okay. So when we say m into n 2D matrix, let us quickly see what are the constraints for m into n. As you can see, m and n are in the range of 1 to 500. Okay, both of them. M is going to be the whole length of the whole array, and n is going to be the length of the each element. Okay, remember it's a string basically. Okay, so the maximum possible length of this is going to be also 500. At the same time, number of elements in this are also going to be at max of 500. Okay, that is what they are trying to say. So yeah, that was a 2D matrix, bank of I representing the ith row. Okay, so consisting of zeros and ones. Zero means the cell is empty, and one means the cell has a security device. Please highlight this part. This is what is most important. See, wherever there is one, we have to do a work there. Okay, as simple as that. We are not bothered about where zeros are there. As simple as that. So yeah, one means cell has a security device. There is one laser beam. See, there are two things here basically. There is something called a security device, and there is also something called a security beam. This question revolves around the security beam. So we'll have to try to understand the relation between the two. Okay, what is security device and how laser beam is associated with it. Okay, so this is how they have associated it. There is one laser beam between any two security devices if both conditions are met. What are the two conditions? The two devices are located on different rows. Yeah, and there is no security devices in the ith row. That means try to understand this. Let me show it in the picture. See, try to understand. For example, if we talk about row 0, it has three security devices. Okay, but there are none in the second row. Okay, there is none in the second row. So directly come to the third row. You can see in the third row we have again two security devices. So a laser beam can be there only. See, first of all, let's talk about this condition. First of all, laser beam can exist only between security device of one row to the security device of another row. As simple as that. Okay. Please know. Please, if you have any pen and paper, please write these conditions down. See, the security beam can exist between two rows. Okay. It cannot be within the row. As simple as that. Next thing is they are trying to say that that security beam will exist only between the row and the very next row which has a security device. So try to understand. See the one. Let me zoom in here. Okay, so you can see the security device of row 1 cannot have a beam with security device of this row 4. Okay, that is idea is the security device of one row will have only a beam with the security device of the very next row which has a device. Okay, as simple as that. For example, see in this case row 1, row 3 and row 4 have devices, right? So please try to understand where these arrows are going. Okay, as you can see, all the arrows of from row 1 are going to row 3 only. Okay, none of the arrows from row 1 are going to row 4. As simple as that. That means the security beam can exist only between a row and the very next row which has a security device. Okay, as simple as that. That's why they're trying to mean through this. Okay, for any row of I where I is between R1 and R2, there are no security devices. So that's what they're trying to say basically. So I hope you have understood the question. So the idea is very simple. We have to find the number of beams. Okay, return the total number of laser beams in the bank. I will again repeat. See, so let us say we are at row 1. Okay, this is what I'm calling row 1. Okay, I have to find number of beams coming out of it. So I have to find for finding that I have to find which row next, that is which row after row 1 has security devices. In this case it is row 3. Okay, because row 2 doesn't have anything, so directly row 3. So now there will be beams from devices of row 1 towards devices of row 3. That's it, right? Then the work of row 1 is over. Next we'll have beams from row 3 towards row 4. Okay, as simple as that. So now coming to the point, how many beams are there? As you can see, for each device of row 1 there will be there will be a beam towards each device of row 3, as simple as that. What that means is, see, suppose I am talking about the first device, it has two beams. Similarly, the second device also two beams are going from it. The third device also two beams are going from it. Why two beams? Because there are two security devices in the next row, the next row which has security device, as simple as that. So the idea here is, so please come to this point. See, this is how you are going to code number of devices in row 1 into number of devices in row 2. Okay, that is row 3 will give me the number of beams. So what is this? 3 devices, right? How many devices are in the row 3? 2. So what is 3 into 2? 6. So please count it by yourself. There are 6 beams. So this is how we are going to find out. Similarly, come to this case, row 3 and row 4. Okay, so if you have to find how many beams are going to be there from row 3 towards row 4, so how many devices are there in row 3? It is 2. How many devices are there in row 4? It is 1. So what is 2 into 1? It is 2. That means two beams will be going from row 3 towards row 4. As simple as that. Okay, that is what we are going to do. So this was the example one, basically the exact same scenario with they have given the picture, in a picture way. If this picture was not there, I guess definitely it would have been difficult to understand what they are doing. But since they have given in the picture form, it becomes very, very easy to code. So now comes in what kind of time complexity you can code it. So I can code it in O of one space. I will show you that how we are doing it. Okay. But I hope the question is clear to you, because otherwise, it will be difficult for you to understand. So please take a moment. If you have not understood till now, pause the video. Try to understand each and every word of it. But what I feel is that you will understand the better if you see this image. Okay. And by the way, the answer is 8. Just try to understand how the answer 8 is coming. See, there is 6 beams coming between row 1 and row 3, and there are two beams coming between row 3 and row 4. So 6 plus 2, the answer is 8. As simple as that. Okay. And yeah, that was it. And if you see in the second example, see, this is the only row which is having the devices. There is no row after that which is having the devices. So obviously there are no beams. So if you have understood this question, yeah, I already discussed the constraints, by the way. There's nothing much to discuss there. So let me come to the coding part, and remember this solution is unique because I'm going to solve it in O of one space complexity. That is, I'm not going to use any data structure related to n. That is, the space I'm going to use is not going to be related to n. Okay, what is n, by the way? N is going to be the length of the bank array, as simple as that. So what? Let us me come to the solution now. See, I'm declaring answer variable, which is going to be my final answer. Initially, I'm keeping it as 0. Okay. See, in this condition, in this question, they have not mentioned anything like -1. See, normally what will happen is they will say that if there is no, beam possible, return -1, something like that. In this question, they have not mentioned that. And in example 2, we have already seen that we have the answer 0 coming. So we can be sure that, yeah, we can return 0. As simple as that. Okay. So I'm declaring the answer with 0. That's what it is. I am declaring two variables here. Please pay attention. One is previous row count of 1. Okay. Next one is current row count of 1. These are the two variables which I will be using throughout this code. So please pay attention to what I'm doing. See, I have taken the case of separately. See, for row 0, I'm taking the case separately, and then I'm using a for loop from row 1 onwards. Okay. So row 0 is treated separately, and then from row 1 onwards, I'm using a loop to find the number of beams. Okay. So what is for row 0 I'm doing? I'm declaring a variable called previous row count of 1. This variable has a meaning, so this time I'm not simply using the variables. I have kept a meaning for them. Okay, they are meaningful variables, the names given, right? Previous row count of 1. Okay, what do you mean by previous row? See, try to understand this. If I have to find the number of beams between row 1 and row 3, so I should know what are the number of devices in row 1 and what are the number of devices in row 3. Only then I can do that, right? That's what I'm doing. So basically the idea here is number of devices in this row 1, I will store it in previous row count of 1, and the number of devices in row 3, I will store it in current row count of 1. Okay, then I will multiply them and get the answer. This is my idea, but let's see how we are doing it. So previous row count of 1, I'm declaring this variable. I'm storing it with number of ones in the 0th element of the bank array. Okay, what is this? Yeah, this is the one. 0th element of the bank array. How many ones are there? That I'm trying to find. Okay, dot count of 1 means in Python how many ones are there in this particular string. Okay, so bank of 0 is that is 0th element of the bank. In that, how many ones are there? That I'm storing in previous row count of 1. Okay, then I'm just taking the length of the bank array as n. Okay, this is simple step. Then I'm starting a for loop. Remember the for loop, the first the value of I will be 1 and not 0. Okay, and it will go till n minus 1. So what I'm doing next, as simple as that. See, I'm trying to find in the ith row, that is, yeah, I starting from 1. In the ith row, how many ones are there? The way I have done it here, the same thing I'm doing it here, but this time it is for the ith row. Remember that. So what I'm calling this variable, I'm calling it current row count of 1. Okay, This is for row 0, and this initially when the row is for the first time, this will be for the row 1. Okay, I'm calling it, yeah. Then I'm checking if in case this is 0. Okay, in case this is 0, which will be the case in the first example. See here, this row 0 is basically this thing for me. Okay, row 1 does not have anything, so this condition will be true. What I'm doing, I'm doing a continue. That means do not execute the below part of the code, that is this part of the code. Simply go to the next loop. Then it will, I will become 2. Then okay, I will become 2. So for 2, this row, we are talking about this row, right? For 2, what I'm doing, I'm again counting the number of ones there. Okay, so how many ones are in the ith row? It's basically 2. That will be stored in current row count of 1. Okay, so this condition will not be true for the row number 2. Okay, so what I'm doing, I am multiplying the previous row count of 1 multiplied with current row count of 1. So what we are basically doing, we are multiplying 3 with 2. Okay, what is 3 into 2? It is 6 that we are going to add to the answer. Remember, it is answer plus equal to. It is not simply plus or simply equal to. It is plus equal to. That basically means answer is equal to answer plus this particular product. Okay, so initially answer is 6. Okay, then I'm doing an important step. What is that? Now whatever is there in my current row count of 1, that is this variable. Okay, this I am storing in now in previous row count of 1. Why I am doing that? Remember, if I have to, for example, see here, if I talk about the last row, if I have to find the number of beams towards it, what I need the number of devices in the very previous row. Okay, only then I can find it, right? So in, see, suppose, yeah, this is row 1, row 2, row 3, and row 4. If I talk about number of beams coming to a row 4, I need the number of devices in row 3. In this case, I'm not bothered about how many devices are there in the first row. That is not of use to me. Only the next, the very previous row which has a device, only that is of use to me. Okay, so when I talk about row 4, number of beams coming towards row 4, I only need to know how many devices are there in the row 3. As simple as that. Okay, so that's why how many devices are there in row 1 is of no use to me. After I count the, see, initially what I will do, I will basically try to find how many, beams are coming towards row 3. Okay, for that I need number of devices in row 1. Okay, once I count that, then the number of beams, that is the number of devices in row 1, is of no use to me. Okay, that's why I, in this place of the, see, initially what it will store in, it will should be storing number of devices in row 1. Okay, but I don't need that after that. Okay, so I am storing this thing in there. Okay, so what will be this value now? This value will be number of devices in row 3. Okay, so now we'll go to next loop. What is the next loop? And then we will come to this part. Okay, and then we'll come to the last, the last row. In the last row, how many devices are there? Basically, in the last row we have one device. Okay, this will be 1 now. This condition will not be true. Okay, so what we are doing, we are multiplying 1. This is what I've highlighted now. The value is 1. And what is this thing, by the way? It is 2. Okay, it is 2. So what is 1 into 2? Answer is 2. So I'm doing plus equal to, that is answer is equal to answer plus the product. So basically answer is 6 initially. So we are doing 6 plus 2, which becomes 8. Okay, which becomes 8. And then again I'm storing this. So what will the last value of this? Now what will the previous value of this? The previous row count of 1, it will become 1. But obviously we are not going to use it because the loop will end here. Okay, and what will return? Will return answer as 8. So let me quickly run this and show you, so that you get the clarity. So as you can see, we are getting 8 as the answer. And if you talk about the second case, in the second case, it's very simple one, because only one row has the devices. So obviously beams cannot be produced, because for beams to be produced, we need at least in 2 rows there are some devices, right? So obviously in this case, we are not having any beams. So I hope we would have understood. And see, if you talk about the time complexity we are using, you can see that I'm using a single for loop, right? In a single for loop, which is O of n, right? As simple as that. But when you talk about space complexity, remember, this is, I'm using some variables like the answer, previous row count of 1, n, and the current row count of 1. These are the 4 variables which I'm using. But remember, they are not dependent on n. Okay, whatever be the number of n, these 4 variables only I will use. Okay, so the idea here is the space going to use is not dependent on n. Okay, so you can call it O of 1 or O of constant. Okay, as whatever you call it. Okay, O of const. As simple as that. So yeah, this is the one. So I hope you have found this example. I understand that. See, after reading this condition, I am not. I'm sure you won't be able to understand everything at once. But yeah, this image makes it very clear. And I hope after going through my explanation, you would have found the question interesting, and also the logic. Okay. See, what normally people will do is that after they see of this, even if you try to see the hints, the hints they are trying to give, what you will do is that you will create array and you will store the number of devices in each row. But remember, that is not needed basically. If you do that, the space complexity will become O of n. Okay, it will become O of n, but that is not needed in this case. We just need the number of devices in the very previous row to count the number of beams towards the current row. As simple as that. So that's why I've coded it in this way. You can also see in Leetcode, you also have some hints, by the way. You can go through them, and if you go through the hints, you will get to know that they are trying to say, if you have the integer array where each element is the number of security device on each row, how you can solve it. So basically they're indicating towards storing number of devices in each row in a separate array. But I am not in favor of that, because we have another, we can reduce the space complexity. We don't have to create array again to store everything. That's what I wanted to say. So yeah, fine, that was all for today. This was the day 3, and okay, we'll surely meet on day 4. Thanks a lot. We'll see you tomorrow.